compute nodes. So we will show you how to start interactive sessions and how to run Julia in a Jupyter notebook. So you have seen that it is possible to run Julia directly on the login node. And if you type the command Julia on the terminal, as I showed you before, then you can run your scripts. But this should be done just for very lightweight, less than seconds jobs, right? So you shouldn't run scripts for data production on the login nodes. And instead of that, you need to write your script and send it to the queue. Otherwise, you can work more interactively, yes, with the interactive tools that we have at our centers. So here is a description of how to use the interactive resources at HPC2N. I will talk in this uh, simultaneous session on HPC2N only. Yeah. So we don't have real interactivity with the compute nodes as in other centers where you can log in to the compute nodes, and then you get a full access to the node where you can run your Julia scripts, for instance. So we don't have this type of interactivity because you cannot log in to the node, right? So instead of that, we have a tool from SLearn called salloc. And here, if you go to this tab, you will see how to start salloc. So here, you start the command salloc. And here you specify the number of tasks that you need. So for instance, one task, then you set the time. I will ask for just 3 minutes. And then the project ID. This is not a 3, it's a 4 here, 2024. And this will start a job on the queue. So if you're curious about that, you can take a look at the queue with the SQ command, and you can see that a job with this job ID is running in the queue, right? So then it means that you have allocated a node, yes, but you are not in that node. Yes, you just allocated the time to run your code on that node. So how to run a code or some job on this compute node that is allocated. In that case, you can use the srun command, yes, as a prefix to your Julia executable. So for instance, now that we have allocated the compute node, this one, yes, we can run some command like hash name. But notice that I need to execute the command with the SROM in the first place. So that will tell me the name of the host where the job is being executed. So if instead of that, I try another way to another parameters for salloc, I can get a different result. Let me see how is this job in the queue. So it's about to expire, so I can cancel it with the scancel command. And it tells me that the location has been revoked. Yeah? Now imagine that I request 4 tasks. Yeah. Then this will allocate 4 tasks per node. And if I execute the command srun, so this will be executed uh, 4 times, as you can see here. So here is important to distinguish between dash n, which is the number of tasks, and also the dash c, which refers to the number of cores. Yeah. So in this case, I can cancel this job. So if instead I want to run, for instance, a threaded program, that is a single program that runs some number of threads, then I need to specify here the number of tasks as 1, and then specify the number of threads with the C command, right? With the C flag. And when I execute the srun, in this case, this will be executed just 1 because I only specified 1, but notice that 4 cores are available for this single task. So this is important to distinguish here dash n and dash c. Yeah? So if you put here 4, it will be executed this command 4 times, as we saw before. Then I can cancel this job. And you see that this is a way to interact with the compute nodes, right? So because you cannot run on HPC2N SSH to the compute node to do this. And here there is a simple program. Here we can copy this and paste it in a job serial.sum.jl, for instance. And it's already there because I pasted that previously. And I imagine that I want to run this job with salloc. So first I need to allocate the resources. I need this time a 1 core, but this is essentially the same as using 1 because by default you will get 1 core per task. So that's why we don't need to write explicitly C1. So we can leave it as a 1 in this case. And this will give me 1 core per task. Okay, we have been granted with this allocation. Then we can run the Julia script with the serial sum.jl code, and then some input arguments, in this case 3 and 4. And this will give me the sum, which is 7. Yeah. So notice that I need the srun, because otherwise, if I execute just this line here, then I will be running on the login node, not on the compute node. Then I can cancel the job as I did previously. Notice that in this case, because we requested 4 cores, 4 tasks, so this calculation is repeated 4 times. So besides this way to run on HPC2N for the interactive jobs, yes. So here I relinquished the allocation. I forgot it by canceling the job, but you can also exit the job, right? By typing exit on the command line, and then your allocation will be revoked. So besides this type of interactivity at HPC2N, we have also the Jupyter notebooks that can run with Julia. And for this, we need to do some prerequisites. So I will start by purging, just to get a clean environment here. And here I will load these modules for Jupyter Lab. Then I need to load the module for Julia. After that, I start a Julia session. Yes. And then I go to the package mode that was covered by Bjorn before. And then I add the iJulia package. So it takes some time, and it should take longer, but it shouldn't take a longer time, but because I already added iJulia, so that it didn't take a long time during this lesson. So once we have added Julia, we need to type build iJulia to set the environmental variables and do some buildings that are required by iJulia. Now it's done, and I can exit this Julia session. So then I have this script here that I will copy, and then I can open a file, for instance, called jupyter.sh, and paste this content here. So notice the line, I need to specify the project, the number of tasks, the time. This is a purging that is recommended, the module for Jupyter Lab that I loaded previously, and the module for Julia. Then I start the Jupyter Lab here. I submit the job. to the queue with the dispatch command, check the status, and it's running, should be running now. I can also check the output, which should be something like slurm and the job ID and out. So if you go to this output file, you can go to a line that contains the string B, CN, and some number here, which is the compute node, HPC2N, and some token. So we can copy this line. I can copy this. Then I go to the menu bar on HPC2N and start a browser there. So then on this line, I will paste the line that I copied already. And you see that it starts a Jupyter notebook. So here, when it says select the kernel, you need to choose the kernel. And I will choose the Julia with the version that I loaded, is the 8.5, 1.8.5. I will select this. This is a message that I get that is related to Dask and is not relevant for now. So now you have the Julia kernel here, and you can do some calculation. For instance, A equal 3, then B equal 4, and then we can print out A plus B. So something has happened with the kernel. Let me see. Julia, select. Okay. It is taking some time to execute this thing. And let me see if I can choose a different kernel here. Let me try a different notebook. Something happened with this kernel, which is not responding. Okay, now it works. So you can see that the kernel was not responding, but now it works. It accepted the 3, then the 4, and then if I want to print out this, so here Julia is working as a simple calculator, but you can do something more complicated. And here I have an example for a Jupyter notebook that we have at HPC2N. And here you can take a look at how to deal with the Jupyter lab in Julia. Here there should be one example. Let me see. Yeah, here sorry, this is the guidelines for using Jupyter lab at HPC2N. And here there is an exercise that you can try for running Julia in a Jupyter notebook. I hope this is helpful for you.